the other possible value is we are going to ensure, right? The other possible value is we want to make sure that stress mean is equal to minus 150 megapascal. Okay, and stress max is equal to 0 megapascal. Right. So we're going to occupy the left hand side. The compression side. So I'm going to start with minus I write a bit of tensile. Okay. So this is our normal stress. And then we have our shearing stress. Element rotate clockwise. Element rotate anti-clockwise. So 20, 40, 60, 80, 20, 40, 60, 80. Okay. I'm going to draw our operating bracket. Okay, so it's 150, 75. On the positive side, I'm not going to be so bothered because I'm not completed drawing. Okay. So it cannot be outside this box again. Okay. Then we are going to use we know our first X point is at minus 70. Right. And then I'm going to draw our 40 line. We'll draw that a 40 line. Right. And we already know that this is our point X. We already know that this is our point X. Right. So the next one is we want the entire circle, right, to just occupy the compression. Right. So I'm going to draw one of the Mohr circle now. Right. All of them are in the compression mode. And then you ask me, Eugene, how is that possible? Right. Point X is not touching any of the circle. It's possible because the bigger circle is not necessarily the in-plane circle, it's the out-of-plane circle. So I'm going to call this point, this point over here is still our point Z, right? That's why I say it's the anchor, okay? Point Z is our anchor. Means this component cannot go beyond this bracket, okay, because of point Z. Because point Z have zero stress, okay? So now, how are we going to construct this, okay? So one possibility, right, is we are going to apply the rules of the circle. I wonder, did I teach the rules of the circle in our Mohr circle? Let me see. Yeah, we did. Okay, so remember we did the rules of the circle. Okay, so I'm going to copy the rules of the circle, and that is in tutorial 10. Okay, I'm going to copy. Okay, and I'm going to paste over here. Oi, where did it go? It went stupid on me. Hold on, let me do it again. Maybe it's the user. Oh, yeah, I told you guys, right? It's the user. Wait, let me undo. Let me come back in here. And let me paste. I don't know why is it always pasting outside. Or let me do a regular paste. Okay, regular paste, it works. Right. So we are going to look at the rules of the circle, right? So if we were to apply the rules of the circle, we know our point X is like our point C. Yes or no? So point A is a 1 point, right? So we know that this has to be what? 90 degrees, okay, for our the other circle, okay? So we know that we're going to connect from here to here. Right? And then I'm going to copy. I'm going to paste. I'm going to rotate this by 90 degrees. Why I need to rotate by 90 degrees? Because this angle over here is always what? 90 degrees. Okay. Right. So this is our the other circle. Okay. So at this point over here, I'll call it my stress A. Okay. So we need to know find our stress A. Okay. Why we need to find our stress A? Then we can draw our XY plane circle, right? So bear with me, okay? Once you see it, it is better, easier for you. So in order to find that, we need to find our I'm going to call this angle alpha, right? If there is alpha over here, is also our alpha. Okay, so we're going to find alpha. So we know that tangent alpha is equal to 40 divided by 10, 20, 30, 40, 50, 60, 70, 80. Is it 80? Yep, divided by 80. So alpha, so 40 divided by 80, inverse tangent is equal to 26.6 degrees. Okay, 26. So if I take my protractor, or if you guys have a protractor, if you draw it, it should be about 26.6 degrees. Yeah, so it's about, yep, it's about 26 degrees. I only can see 26 degrees. So to get stress A, right? So now we want to find the position of stress A, right? So position of stress A will be, okay, so stress A will be equal to minus 70 plus by so for this case is 40 tangent 26.6. Okay, so tangent times 40, so this is equal to minus, so tangent 26.6 equal to times by 40, so it's minus 70 plus by 20. Okay, so this is equal to minus 50 MPa. Okay, so if you see, we have drawn also at minus, so at minus 50, right? So when that's the case, we can calculate our stress average is equal to minus 50 plus by minus 150 divided by 2. So this is equal to minus 100 megapascal, right? So we know that the stress average, okay, this is our stress average, okay? So we can directly now draw a line. Okay. So this point will be known as our y2. Okay, will be known as our y2. So when it's the case, you can draw the other Mohr circle. Right, you can construct the other Mohr circle. So the other Mohr circle is at 50. Go on. Somehow, my bad. I drew at the wrong point. It's to intersect the. Yeah, I got confused. Okay. So this over here, right, is your y2. Okay, your y2. So next, we just need to find our y2 value. Okay, so if we obey the rules of the circle again, right? So this angle over here is equal to 2 alpha, right? So this angle over here is also our 2 alpha. Okay, so I'm going to draw a line to indicate our stress average on the smaller circle. So before I go any further, the smaller circle now we have drawn now belongs to your XY plane. And this is your in plane. And the first circle that we have drawn, the big one, right? The big one over here, this in fact belongs to our YZ plane. And this is our out of plane. Right? So now we find stress Y2. Right? So stress Y2 is equal to minus 100. Right? Then minus by tangent minus by tangent. Wait, I'm having a bit of brain not working. So let me do some side work. So tangent is this divided by this. Or you can use sine, okay? So not necessarily you can use cosine because you know the radius, right? The radius is at 50. Okay. So you know that cosine 50 cos 2 alpha times by 26.6. Okay. So it will be equal to 26.6 times 2 cos times 50. So it's at 130 MPa. Okay. Or you can also do this. Okay. So you also know that wait, another way of doing it. I'm trying to use tangent. Can I? Yeah, you can also use tangent. So stress Y2 is equal to minus 100 minus by tangent 2 times by 26.6 divided by 40, right? Because you know the height. So 26.6 times 2 tangent divided by 40. Wait. It's not divided by 40. So 26.6 times 2 tangent. Okay. So 40 divided by. Okay. So sorry. This is 40 divided by tangent 2 times by 26.6. Right. So this will be equal to. So 40 divided by tangent bracket 2 times by 26.6 close bracket. So plus by 1. So it's also equal to minus 130 megapascal. Okay. So the other possible value